All right, welcome to a new video. So today we're going to do this easy problem called valid anagram 242, and I'm going to go through it using my explore process, which is to get user input and output, go through some examples. Then after that, I like to match what kind of approach we can do, and yeah, implement and then review and evaluate. So yeah, let's do this. So when I like to explore my problem, first off, I like to just read the problem like twice or more so I can get my input and output correctly, right? So yeah, let's do that. So given two strings, S and T, so we're gonna have two strings. Return true if T is the anagram of S and false otherwise. So basically, going to check if the second word is an anagram of the first one. And we're given that an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original characters letters at least once. Okay, so um yeah, let's get the input and output. So let's by reading the column again. We're given two strings S and T. So two strings S and T. And then the output, if I remember correctly, is going to be a bool. I'm going to say true if if S, yeah, if T is an anagram of S, and false if not anagram. And then we can note, because we don't know what an anagram is, right? So basically, anagram is rearranging a word, rearranging of another word, and they use same letters once, right? Use all same letters. Use all same letters once. So for example, um, let's go through some examples now that we know the input and output. So let's say for example, we have the input to be rack, I guess. I don't know what actual word would there be that isn't like an actual anagram, but I guess an anagram is arc. Oh wait, no, input is rack because we have two strings, right? S and T. So S is equal to rack, and then T is equal to arc. Right? So we have to check that T is an anagram of S. So if we go through it, an anagram is a word rearranging of another word using all the same letters once. Okay, so we have R here, and then there is an R in T, then there's an A here, then there's an A in T, there's a C here, and then there's a C in T. So we can say that all the letters do appear once, right? So we can say that it's true that T is an anagram of S. Let's go through another example. I want this example to be true as well, but make it harder, I guess. Um, maybe the same thing. Oh no, let's have duplicates in there. So let's say we have ABBA, like the artist, right? Is that the artist? I don't know. You can check it up on Spotify. ABBA. Oh, ABBA. Yeah, ABBA. Make sure I'm saying it wrong. Let's say so S is ABBA, and then T is going to be Baba. I don't know. And so if you go through it with the definition of an anagram, right? So we have an A here. There's an A here as well. There's a B here. There's a B here as well. There's another B here. There's a B there too. Then there's an A here. There's an A here too. So basically, we have two occurrences of A's and two occurrences of B's, but they're just rearranged in like an anagram way, right, as described. So output is going to be true because it is true that T is an anagram of S. We have all the same letters and the amount of letters, but just in a different arrangement, right? So let's go with an example that is going to be false, like 100%. So let's say we have the input of Zaza, and then T is going to be Lloyd, right? So if we go through this, there's no occurrences of Z and T. There's no occurrences of A and T. So that means that T is not an anagram of S, like 100%, right? So we're going to say false, right? But what if, like, an edge case, right? We're given like an empty string on either side. So like input is equal to like Zaza again, and then we're given an empty string denoted by these two empty quotation marks with nothing in them. I'm pretty sure it'll still be false, right? This is kind of like an edge case. What about we have another example of like where the input is also empty for S and there's empty for T. I guess we could say that it is an anagram as well because they're both empty, right? So we can say true maybe. I'll like that's a good question for like the interviewer, right? Just to like define some edge cases. So we've gone through numerous examples, 1, 2, 3, 4, 5. So I feel like we kind of do understand the problem. So let's go through some approaches that we can do to solve this problem, right? I like to call that the matching phase. So what comes to mind is we can definitely do some for loops, for loop and a list, like two lists, I guess. I'm not sure. For loops and two lists to denote if we've seen and is in, I guess. Just being very vague. Or we can do a dictionary and that will hold occurrences of both. So kind of like storing, but we have like a number. So like a letter and the number of occurrences that they have each. And then we can like compare dictionaries, I guess. I'm not sure how the comparison of dictionaries would work. Maybe maybe the key and value pairs have to be in a certain order. I'm not sure. But I'm guessing that there's no specific order. They just compare the key and value pairs, like if they're the same. So I think that's what's going to happen. And we can also use counter. It's kind of the same thing. We kind of compare the counter um, data structure. I'm not sure how the counter data structure works, if it's like just a dictionary, or if we can just like compare counters without having to do anything special. We can just say like counter is equal to counter. Um, so yeah, by counter, I'm meaning like we're going to take in a string, and the counter is going to count how many letters are in the string. And then if both counter data structures are equal to each other, like in terms of key value pairs, then that means that they are anagrams of each other, right? So we can do that. Compare counter data structures. Not sure if it's a data structure or not, but it's kind of like a dictionary, but it does the counting for you. So, so since this is a problem that I've kind of done with dictionaries before, like a long time ago, I think since I haven't done counters in a while, I mean, I have barely any knowledge of counters, and I feel like they could be like a helpful tool for me in the future, and I don't know much about it. I think I'm gonna go with the approach of a counter, so I can just learn from the process, right? Let's go with the flow, basically. So 100%, I'm gonna go for this one. Let me start. Let me go for that first. So now that we know what kind of approach that we're gonna go with in general, like what we're gonna use as a tool, let's go make a plan for this, right? So with my plan, I just like to do some pseudocode, like in sentences, and then some actual code that goes with the code in English. So the first thing that I want to do in my program is I want to get user input of S and T. So I'm just gonna blatantly say get user input of S and T, strings. Then I can say S and T is going to be equal to input. Yeah, it's going to be equal to input, right? And then once we get the user input, um I want to import counters. So import counters to use. And then after that, I want to use counters for S and T to hold occurrences. So I'm going to say that S counter is going to equal to like counter with S, and I can also say that TC, which is T counter, equal to counter of T, And then what I want to do is I want to compare counters. So compare counters if they are equal in occurrences. So it's going to return if SC equals to TC. I'm not sure if how that works, but I'll see in the code, right? Or I can just search it up while I'm doing this problem. Okay, so my plan kind of makes sense. We already know how counters work. Like they basically do like O of n iterations over the string to count the amount of occurrences in the string, right? I mean the letters in the string, how many times it's occurred in the string. And then we're going to see if they're equal to each other. It's basically, the anagram is basically getting the original characters in a string and then seeing if those exact characters are in the other string, like the exact amount of times. So for example, we have one R, one A, one C, and the S string, and then the exact same amount of occurrences in the T string. So that's true. So basically have one R, one A, one C. And here we have one R, one A, one C in here as well. So that's why it's true. So if we can do the same thing here, um, in code, then that means we can solve the problem easily, right? So I feel like my plan kind of works. I'm confident that it does work, but I'm not confident about this part, like how to compare counter objects. So let's just do the code and see what happens, right? So before I actually start with my plan, I'm going to make a driver, pass that for now, then run it in the code itself. Then I'm going to make a function that actually solves the problem. So def check is valid, I guess. And I'm going to give it the arguments of s and t, so s and t. Then I'm going to pass it for now. Oops, much parentheses, pass it for now. So it looks good. No more red lines. So yeah, so now we can start with our plan. So the first part of my plan is to get user input of s and t as strings. So s is going to be equal to the input, and then t is going to be equal to the input as well. And then I want to call is valid with arguments of s and t. So is valid. I'm going to give the arguments of s and t. And then I know that this function is going to return a boolean, and I'm just going to print out the result, the return value, as I call the function. So we're going to call it is valid, give it the arguments of s and t. Then we're going to go through this line of, we're going to go through this function and then print out its return value, right? So now that we know that, let's just go ahead and code and continue with our plan. So second step is to import counters to use. So I'm pretty sure we can just say import, no, from collections, that's the library. We're gonna import counter. That's capital C, okay, cool. But now we can just create counters. So sc is gonna equal to counter, and we're going to count s, and then I think I can do this as well. Or tc is equal to counter, we're gonna count t. Oops, I think I make that uppercase. That looks good. And then we're going to return if sc is equal to tc. And before that, I run the code, I'm going to like double check if we can do that. So I'm going to Google like, can we compare counter objects in Python? Okay, so I didn't read it close enough. Where does it say? Okay, so yeah, I didn't read it close enough, but they do support comparison operators for equality and stuff like that. So my code will work for sure. I just want to double check because I have no knowledge of counters. Like I have no wide knowledge. I just have very little that it can like count for you without having to do like a for loop. But it's still the same time complexity, which is O of n. It goes through every element in the list or a string. But either way, we got it. So pretty sure this is going to work. Let's test this with my examples. So if I give it arguments of RAC, oops, RAC, and then ARC should return true. But just to make sure, oopsie, what happened? I don't know. Let's make sure that it doesn't work with Zaza and Lloyd. Lloyd. False. Okay, cool. So I think it's good. I'm pretty sure it's good. So to review its complexities, we know that counters, as I said before, just like a couple of seconds ago, that counters iterate through the whole string or list, so it's O of n time because it goes through every element in the string or list. And then for space complexity, it's still O of n because for every element of the input we're given, so O of n, we're going to store those elements um, each uniquely in a dictionary, basically, dictionary-like structure. So it is O of n space as well. Um, yeah, so that's pretty general. I think there should be a better solution with O of 1 space. Um, but yeah, I think this is fine. I'll probably look up another solution later on after this. But yeah, I feel like this is fine. So what I'm going to do is I'm going to just copy and paste my code into LeetCode and see what happens. It should be accepting, hopefully. Yeah, and before this, I do have to import from collections. I have to import counters, not pointers, but counters. The counter? Yeah, just counter. Okay, cool. So let's just run this. Accepted with these test cases. So let's go submit it and see if it passes all the test cases. Okay, cool, it does. Runtime of 40 milliseconds and it beats 92% of solutions. So that's pretty good. But yeah, that was my thought process and communication process of what's this problem called again? Of 242 valid anagram on LeetCode, which is an easy question.